Hi class, I had promised you one more math review session, this one about units. So units are one of the things that you may have encountered before if you've taken physics or chemistry, but it's actually one of the most important math, but let's call it a science skill that you can have, because it's the one thing that you can do to help you understand what it is you're talking about, and it's the one thing that you can use to your advantage to put things in context and make some of the values and ideas and sizes of things that you encounter in astronomy able to wrap your brain around. So fundamentally, a unit is nothing that nature knows about. It's something that humans have constructed so that we can describe the world. And every number that we say in astronomy has a unit with it, because otherwise you don't know what we're talking about. So as an example, we've previously talked about the sun, and in a previous example we used Alpha Centauri, which is the nearest star to the sun, as an example. And I could make the statement that Alpha Centauri is 4.3 from the sun. Okay, what does that mean? 4.3 what? If you don't have a unit, you don't have any idea what I'm talking about. 4.3 miles, 4.3 minutes, 4.3 key lime pies, who knows? You have no idea what I mean unless I put a unit with that. And the unit is the statement of what it is we're actually measuring when we report a number. So in this case, when I say 4.3, the distance between the sun and Alpha Centauri is 4.3 light years. Okay, and that's really important to know. Light is the fastest thing in the universe, and a light year is not a time, it's the distance that light travels in a year. So this is the distance between Alpha Centauri, is the distance that light can travel in 4.3 years. In other words, it's a really, really far distance. Now, most of the units you encounter in your life are not enormous like this. And so for almost everything that we do, we're going to use what in the United States we commonly call the metric system. Okay, every country in the world, except for 2 or 3, the United States being one of them, uses the metric system, and scientists in particular use the metric system. It has nice properties, but it actually helps us communicate, so we all are talking about the same things all the time. Now, this is more properly called SI, or System International. That comes from the original French origins of this system. But fundamentally, the metric system is a system built of 3 quantities. Whenever you're measuring distance, the unit is the meter, which is abbreviated with a little m. Whenever you're measuring mass, that is how much stuff is in something, the unit is the kilogram, which is abbreviated kg. And anytime you're measuring time, the fundamental unit is the second. And that's abbreviated S. Okay, and so here you can see the other name that we often use for the metric system. You'll often hear physicists or astronomers call this the MKS system, for meters, kilograms, and seconds. Okay? Now, these normal values that we use for MKS units are conventional units that are suitable to the things you encounter in everyday life. How big is your car? It's about 4 meters long. How much does your cat weigh? Well, he weighs about 3 kilograms. 3 kilograms? Yeah, that's about right. How long do you cook an egg? Well, you cook it for about 60 seconds. Okay, so these units are very conventional and useful for our everyday life. But in astronomy, we will sometimes find that those units are useful, but in other instances, we will find that we need to have units which are easier to describe, because if I were to use these units, I'd have to use enormous numbers. So for instance, if I were to ask you what is the distance to the moon from the Earth, if I express it in meters, the distance to the moon is 3,474,200 meters away. Okay, and that's a really big number. Now, you and I have learned scientific notation, so we could write this in scientific notation, of course. I could write that the moon is 3.47 times 10 to the 6 meters away. Okay, that's better, but there are other ways in the metric system to write this number more succinctly. Okay, and the way you do that is you use what are called prefixes. So prefixes are a multiplier. Okay, and there's a table of them here, and you can look these up in your book or you'll see them online. The prefix is a multiplier that you can put in front of a unit that corresponds to a particular value written in scientific notation. So for the moon, we had just said that the distance to the moon is 3.47 times 10 to the 6 meters. Okay, so if I were to look at my table here, what I see is we have a prefix name for 10 to the 6 meters. 10 to the 6 is mega, whatever unit you're talking about. In this case, we're talking about meters. So I could just as easily write 3.47 times 10 to the 6 meters. The way metric prefixes work is I combine the power of 10 and the name of the unit together and replace it with the prefix name. So in this case, 3.47 times 10 to the 6 meters could be written as 3.47 mega, capital M, meters, little m. Okay, so that's one way that this could work. Now, I will point out that you are using this already that you don't, maybe aren't used to. The typical distance that we report distances, say on the highway in a mile, is usually converted into kilometers. 1 kilometer, hey Lyra, there's my cat. I don't know if you can see her. She's standing right here. 1 kilometer is 1,000 meters. Okay? So we here have, which is, I should say, 1 times 10 to the 3 meters. The kilometer is doing exactly what we've said before. It's using that power of 10 and the meter together and replacing it with a metric prefix, in this case, kilo. Okay? Now, the question is, what do we need to know about units? Well, the thing you need to know about units is how to do unit conversion. Okay, and that's the single most common operation you will have to do. Most of you can kind of do this in your head. You know how to do it, but I wanted to formally lay it out so that when you encounter strange units, you can do it at will. What I mean by you know how to do it in your head, if I ask you how many seconds are in 3 minutes, most of you will tell me that it's 180 seconds. Well, how did you get that? Well, you know that there's 60 seconds in a minute, and so you multiply 3 minutes by 60 seconds in a minute, and you get 180 seconds. Okay, so you just did a whole bunch of multiplication of units, multiplication of fractions in your head, and that's all unit conversion is. So I just want to write that out formally so you see how it's done. Okay, so let's take an example, and I did not write this out ahead of time, so let me cover up the answer so you can just read the question here. Okay, so here's the kind of question we might encounter, right? A future astronaut recovers an exotic leaf from an exoplanet that orbits Beta Reticuli, and he records the length of the leaf as 9.75 inches. Now, you and I, being good scientists, know that the JEDI archive forbids recording any number that is not in metric. And so we want to convert that 9.75 inches into meters so that we can record it for future scientists to know. Okay, so how do we do that? Okay, so the way we do that is we have to know some unit conversions. There is a conversion directly from inches to meters, but I'm going to do 2 unit conversions here together to illustrate how we normally do this. And so I'm going to use 2 unit conversions that I know. So in my head, I carry around the fact that 2.54 centimeters is exactly the same thing as 1 inch. Okay, and I'm going to write it as a fraction because this is how we'll use it in unit conversion. The other unit that I carry around in my head, and I know this from our table of metric prefixes, is that 1 meter is exactly the same thing as 100 centimeters, and I'll also write that as a fraction. Okay, so how do we do a unit conversion? Well, we know the length of our leaf, which I'll write as L right here. The astronaut foolishly reported it to us as 9.75 inches. Okay, and so now I want to convert those inches into meters. Now, I've written my unit conversions here in a particular way with a number in a certain order, one over the other, but you can use this either way. You could write this as 1 inch over 2.54 centimeters, or write it as 2.54 centimeters over 1 inch. And the way you write it depends on what you're trying to do here. So here we have something in inches, and we want to get rid of inches. We're trying to get back to metric. And so I'm going to use this fraction in such a way that if the inches were written as a fraction, it would cancel out with the other inches. Okay, so here I'm going to write this as 2.54 centimeters divided by 1 inch. I need to convert those centimeters to meters, so I'm going to use this unit conversion also to cancel out the centimeters and leave me with meters. So I'm going to write that as 1 meter per 100 centimeters. And what I mean by cancel out is that if I think of all of this as fractions, the inches in numerators cancel with inches in denominators. The centimeters in numerators cancel with centimeters in denominators, and you'll see all the units have canceled out, and what I'm left with is meters. So if I were to write that out now, let me write the numbers together, and then I'll do the calculation on my calculator. This now becomes 9.75, the inches have canceled out, 2.54, the centimeters have canceled out, times 1 meter. All of that is divided by 1, the inches have canceled out, times 100, the centimeters have canceled out, and if I punch all of that into my calculator, I get 0.248 meters. So that is the unit conversion of that 9.75 inches into metric. Now we're going to use this kind of unit conversion over and over and over again. In the notes associated with this, if you go read them, I give you a little bit of philosophical justification about it. That relates to the fact that 2.54 is centimeters is exactly the same thing as 1 inch. So if I have something and I divide it by itself, it's 1. So multiplying anything by 1 leaves me with the exact same thing that I have, and that's makes perfect sense because 9.75 inches is exactly the same thing as 0.248 meters. Okay, so there's a little bit of philosophy there. But we're going to very often take our calculations and our numbers, maybe they're in meters, maybe they're in kilometers, maybe they're in seconds, and we're going to convert them into more useful astronomical values. Kilometers to light years, seconds to years, so that we can manipulate and talk about the world in a little bit easier way. Okay, so this is how unit conversion works. If you've never seen it before, you can work through this example and practice a little bit. When we come to it in class, I will do it explicitly out the first few times. When you see it on homework, you'll have to do it sometimes and you'll get a little bit of practice there as well. Okay, so good luck everyone, and we'll talk to you later.